So it says if the numerator and denominator have a 0 in common, meaning a factor in common, there will be a hole in the function's graph. So to graph the function, first factor the numerator and denominator to cancel basically any common factors. Then find the hole by evaluating the new function that's created by canceling the factors at the undefined value. So basically, if we cancel x plus 3 over x plus 3, the undefined value would be at -3, because -3 plus 3 is 0. So you're going to take the -3 and plug it into the new function, and that's how you find where the hole is. So we're going to kind of go through these four on the front page together. So here's my first function. So before you start doing all your work over there, you want to check if I can simplify the function any more than it already is. So you're going to have to factor the numerator. So I'm looking for the factors of -2 that add up to -1. So it'd be x minus 2 times x plus 1. This is why you need your polynomial skills to be strong to be able to factor. And then the denominator, I can factor out a greatest common factor of x, and I'd have x minus 2 left in the denominator. So can you see that I have x minus 2's both on top and bottom? So those cancel. Right? So my actual function that I'm going to graph down here is x plus 1 over x. So this is the function that I'm going to answer every question about over there. The y-intercept, the x-intercept, the asymptotes, and then at the very end, step kind of 5 is going to be to find the hole. So there's going to be a hole at x equals 2, because that's what it would have made this denominator be undefined, right? Normally there would have been an asymptote at 2, but I canceled it out. So I don't see that factor over here at all. So I get to graph this function exactly as is, and then at the very end, I'm going to put a hole at x equals 2. So let's go through our list here. So when I plug in 0 for x, what do I get as my y-intercept? So I'd get 1 over 0, right? So there's no y-intercept. So I'm going to skip to the next step. What would make my numerator equal 0? Right? Because that's going to be my x-intercept. So what does x have to be to get an x-intercept? Someone tell me. -1. Right? -1 plus 1 is 0. So I have an x-intercept at -1. So I'm going to plot that on my graph. What will make the denominator undefined of this function over here? What's my restriction here? X can't be 0. So I'm going to put a dotted line here for my vertical asymptote at 0. Kind of hard to see on the axis, so slanting it a little bit. So my last step is determining if there's horizontal or slant asymptotes. So the power of the numerator is 1, and the power of the denominator is 1. So the coefficients of x are 1 divided by 1, which is 1. So my horizontal asymptote is at y equals 1. So there's my asymptote. So I can tell what the graph is doing in the bottom left corner, right? It's hugging this asymptote and then shooting down through the axis that direction. So to find if it's up here or down here, I'm assuming it's up top because there's no other x-intercept. I should plug in a point. So I'm going to plug in x equals 1. So if I plug in 1 over here, I get 2 divided by 1, which is 2. So I know that the point 1, 2 is on this elbow of the graph. So that would have been as far as you would have had to go in the past. But this wasn't our original function, right? Our original function had this additional factor that we canceled out. So because we canceled it out, the original function was undefined at x equals 2. So I need to plug 2 into my new function, right? So 2 plus 1 divided by 2 is where my hole is. So my hole is going to be at 2, 3 halves. So at 2, 1.5, I just need to indicate on my graph with like an open circle that there would be a hole there. So 1, 2 was just a random point that I graphed, but 2, 3 halves is a hole. So it didn't change the graph except making one tiny value undefined. So whole is different than an asymptote because the whole graph is continuous, but you're just taking out that one little point right there. So that's it. So you just have to be on the lookouts for holes. So number 2, I did, and it should be a little bit easier because this is already in factored form. So this one again has those common factors of x minus 2 that I can get rid of. So my new function that I'm worried about is just, 3 times x minus 5 over x plus 1. Leave it in factored form because you can see everything that you need. You can see your x-intercept, your vertical asymptote. I think it's easier like this. I'm just going to write down that at 2 there's a hole so that I remember at the end there's going to be a hole at 2 because that canceled out. So let's answer our questions together. So if I plug in 0, I might actually have to do the work this time. So 3 times negative 5 is negative 15, and then 0 plus 1 is just 1. So my y-intercept is at negative 15. So I'm just going to plot a point way down here, right, to show that my y-intercept is like way down here on the graph, but there is one. What is my x-intercept? So when I plug in 0, or when I want the numerator to be 0, what do I get? Is my x-intercept? Not everyone at once. What is going to make this numerator equal 0? 5. So 5 is my x-intercept. 1, 2, 3, 4, 5. Plot that point. What is going to make my denominator 0? Negative 1. So vertical asymptote at negative 1. So I can kind of start seeing what this graph's going to look like. It's going to curve up this way. Now I need to find my horizontal or slant asymptote. They both have a linear factor, so they both have a degree of 1, so they tie. And the coefficients of x would actually be 3x over 1x. So y equals 3 would be my horizontal asymptote. So that kind of makes sense that that elbow kind of comes up here all the way like that. So I'm guessing that my other part of the graph is up here in this top quadrant because there's no other x-intercepts that I know of, and it can't go up here because that would be on top of this section. So I'm going to plug in the point negative 2 because that's on the left side of this asymptote. So let's see, if I plug in negative 2, I would have 3 times negative 7 divided by negative 1, which is what, positive 21? So at the point negative 2, my graph shoots all the way up here to positive 21. I just can't really fit that. So negative 2 comma 21 is my key point that I can't quite fit, but I know it goes there. So my last step is I have to find my hole. So I have to plug 2 into this new function. So I'm going to say 3 times 2 minus 5 over 2 plus 1 and see what I get. So let's see, 3 times negative 3 is a numerator of negative 9, and I'm dividing by positive 3. So negative 9 divided by positive 3 is negative 3. So my hole is at 2 comma negative 3. So let's see, 2 comma negative 3 would be like this point on the graph. I didn't quite go through there, but you get the idea. And it should make sense that the hole is where you put your graph. If those things don't match up, like, oh, there's no graph right there. Either you graphed this section wrong or you calculated the hole wrong. It all should fit together like holding hands. Like the hole should be part of your graph. Does that kind of make sense? Any questions on holes so far? I'll do one more with you, and then I'd like you to try maybe number 4 on your own, and we'll check our work together. So let's see, number 3. So I have to start by factoring. I use the hole or the idea of a whole to help me factor the denominator. Because a lot of times if I see 2x minus 1 up here, I want to check if 2x minus 1 is a factor in the denominator. So sometimes to save time with your box method, you could just use 2x minus 1 as one of your factors and see if you can make it work. And if it doesn't work, then there isn't a whole. So if this was 2x, this would have to be x, right? Because 2x times x is 2x squared. And then negative 1 times negative 3 would give me positive 3. So does my outer plus my inner work? Let's see, I would get negative 6x, negative 1x. Yep, that's negative 7x. So use the idea of wholes sometimes to help you factor, because it might just work. So 2x minus 1's cancel. Be very careful when you write out your new function, because this is a mistake that I see. X minus 3 is a factor of the denominator. If the numerator cancels, then it's anything divided by itself is 1. So it should be 1 over x minus 3. And let's just say that this was flip-flopped and you had x minus 3 left in the numerator. Then you just have the function x minus 3, which is a linear function. So you'd have a straight line with a hole in it. But this is still a rational function because it's in the denominator. So let's go through and answer the questions. Where's my hole going to be, by the way? So where is my hole going to be? If 2x minus 1 was a factor, what number when I plug it in would have given me 0? So if I set 2x minus 1 equal to 0, what would I get for x? 1/2, because I would add 1 to the other side and divide by 2. So I'm going to have a hole at 1/2. So I'm just going to remember that for the end. So I'm going to do my y-intercept first. So plug in 0. What do you get? So that's gone. So negative 1/3. So 0, negative 1/3 is somewhere in there. Let's see, x-intercept. I'm not going to have any, right? Because my numerator is always going to be 1. Can never be 0. So no x-intercepts. Vertical asymptote. What is going to make my denominator undefined? Looks like positive 3. Whoa. So positive 3, 1, 2, 3. All right, so there's my vertical asymptote at 3. And let's see, the denominator has the bigger power this time. So I just have a horizontal asymptote at y equals 0, which should make sense because I did not have any x-intercepts. So it makes sense why there's no x-intercepts. So I can see what this side of the graph is doing, right? It's kind of curling down and around through the y-axis. Up here, I'm probably up in the top quadrant, so I'm going to plug in the point 1, 2, 3, 4 for x. If I plug in 4, don't I just get 1 over 1 is 1? So I get the point 4, 1. 4, 1 is about here. So there's the other part of my graph. So my last step is I have a hole at 1/2. So I'm plugging in 1/2. 1 over 1/2 minus 3. What is that? 1 divided by 2.5. Divided by negative 2.5, which is what? Negative 5/2. So the reciprocal would be, is that negative 2/5? Does that sound right for mental math here? 1 divided by negative 2.5 is negative 0.4, right? Which is negative 2/5. Or if you just want to say negative 0.4. So I'm at, where am I going to write this? Positive 1/2, negative 0.4 is my hole. So positive 1/2, it's like right there. Hard to show, but there's my hole. At 1/2, negative 0.4. So it's a lot, because then at the very end, there could be this kind of step 5. So y-intercept, x-intercept, vertical asymptote, horizontal slant. Kind of step 5 is there's a hole if it's applicable. So I'd like you to pause the video. I'm going to write the answers down. You're going to try example 4 on your own.